26, find y triple prime if y equals cosine of 7x. All right, so I need to take the derivative 3 times. Since I've got something in parentheses, I am going to let that be u, so we'll just rewrite this as cosine u. Alrighty, so to find the first derivative, the derivative of cosine is negative sine u times the derivative of the u. The derivative of 7x would be 7. So if I rewrote that, would be negative 7 sine u. Okay, let's keep going here. The second derivative, the derivative of sine is cosine, so this will be negative 7 cosine u. But again, I have to multiply by the derivative of the u, so the derivative of 7x is again 7. So simplifying this answer, it's going to be negative 49 cosine u. All right, I have to go one more time. When I take the derivative of this, again, the derivative of cosine u is negative sine u, so this is going to be positive 49 sine u. And once again, we have to multiply by the derivative of u. The derivative of 7x is again 7. 49 times 7 is, I do not know off the top of my head, so let's just figure this out here. 3, 6, 28 plus 4 is 343. So this will be 343 sine of u, and we can put our u back in finally. So that would be my third derivative. Alrighty, 27, find the derivative at the point 3 1/3. So I notice we're going to have to use implicit differentiation. On the left side, we have a product, so I'll have to have an f and a g. F prime is 3x squared. G prime, since it's actually 1, but I do have to take the derivative of the y also, and we're going to put dy dx, because I'm taking the derivative of y with respect to x. Alrighty, finding the derivative now, the f prime g, so f prime times g plus f times g prime, and then equals the derivative of 9, since 9 is a constant, is 0. Alright, now I'm going to solve for dy dx, so 3x squared dy dx is equal to negative 3x squared y, and then to get dy dx by itself, I'll divide both sides by 3x squared. I think I did something wrong here, because when I took the derivative of f prime, I did not get 3x squared, I actually got 6x. So let's change this up. Whoop, that stays the same. There we go. Alrighty. Okay, so let's just rewrite this. I have 3x squared dy dx equals 6xy negative 6xy over 3x squared. All right, so I have dy dx is equal to negative 6xy over 3x squared. If you would like to simplify this at this point, you certainly may. I think I will, so it's easier to plug things in. I notice that 6 divided by 3 is 2, so I'll have negative 2. I do notice that one of the x's will cancel and it will leave an x on the bottom, so I'll have negative 2y over x. You don't have to do that step, but I personally find it easier. All right, I know my y value is 1/3, and I know my x value is 3. Okay, so up top, I'm going to put a 1 underneath my 2. Multiply across, I'll get negative 2/3 divided by 3. Remember, really, when we have 3 on the bottom, that's like 3 over 1. So since I'm dividing two fractions, it's actually going to be negative 2/3 times 1/3. And now multiplying across, I get negative 2/9. And we've got it. Right, question number 29, again, finding the derivative. Again, we will use implicit differentiation. The derivative, since there's a plus sign, we'll just take the derivative of each part separately. The derivative of tangent is secant squared, so I'll have 2 secant squared y, but since I am having a y there, we do have to include the dy dx, plus the derivative of 5x cubed is 15x squared, and then equals the derivative of 4y squared is 8y, and once again, we need to include the dy dx. All right. Everything that has a dy dx needs to stay on the same side. I think I'll personally move that over to the other side by subtracting it. So I will now have 15x squared equals 8y dy dx minus 2 secant squared y dy dx. Okay, I now notice they both have a dy dx, so I'm going to factor that out. So I'm going to have 8y minus 2 secant squared y. And then from here, we'll just divide both sides by what's sitting next to that dy dx. So I will get dy dx is equal to 15x squared over 8y minus 2 secant squared y. All right, you will notice that if you brought things the other way, you will have ended up with negative 15x squared over negative 8y plus 2 secant squared y. Those are identical answers, so we are good to go. Problem 29 and 30. All right, we are given the graph of f prime. We want to find out where f is decreasing, and then we want to find points of inflection. So I first of all would like to make an f prime chart. And if I'm making an f prime chart, and this is f prime, I'm mostly going to be looking for where is my graph above and below the x-axis. It is below the x-axis until I get to 0, so my derivative will be negative. It's above the x-axis till I get to 2, so that my y values will be positive. And then after 2, the derivative is below the x-axis, so it will be a negative value. So if I'm looking for where is f decreasing, I mostly am just looking for where my f prime is negative. So since my interval started at -4, my interval will go from -4 to 0, and then from 2 to the end of the interval, which is 3. It is decreasing on those intervals because f prime is negative. Okay, number 30 asks for points of inflection. Points of inflection, we need f double prime. And I know if I'm at f prime and I'd like to get to f double prime, I'm going to look at the slopes of the curves. I know that the slopes are positive because my graph is going up until I get to 1. So positive till I get to 1. And then the slopes are negative because my graph is going down. So my f double prime will be negative. So if I want points of inflection, that would be where the second derivative changes sign. And I do notice, yes, indeed, it is changing sign at x equals 1. So x equals 1 is a point of inflection, and that would be because f double prime is changing signs. So we are good to go now.